I know some of you are excited, hopefully. Maybe not. No, we'd rather be at home still sleeping, probably. Okay, so our warm-up today is not out of our Star Master book, but I've made some problems that I wanted us to work on. And I've pulled these problems from old Star Test. Okay, so if these are easy for you, then that's great. So let's look at number 1. It says Gerardo bought 3 packages of mint gum and 2 packages of bubble gum. Each package had 8 pieces of gum. How many pieces of gum did Gerardo buy? So who can tell me what they did on this problem, or what you think this problem is asking us to find? Bryson?
Like, he didn't buy 8 pieces of gum. The total, there's 8 pieces of gum, and he bought 2 packages of bubble gum, and then so there's 8
Good.
in each.
Yes, you're right. There's 8 pieces in each pack of bubble gum. So we need to find the total amount of pieces, right? So if you look over at the corner of the room, that pink poster where it says telling the difference between a multiplication and division word problem. If it's asking you for the total, that means you are multiplying. That's the first one underneath the multiplication side of that poster. Everybody see it?
No.
Multiplication is when you are asked for the total. And it doesn't come out and say what is the total, but it says how many pieces of gum did he buy. So we need to find the total. So I can add up the packages, right? 3 packages plus 2 packages. How many packages is that?
5.
5. So that's like saying 5 groups of 8. 5 times 8.
40.
Okay? And to save me from having to draw a picture or to do equal groups or an array, what could I do? Skip count. Okay? 5 times 8 would be 40 pieces if you skip count by 5s. Okay? Any questions on that one?
No.
Raise your hand if you got it right. Okay, good. You told us what to do and you got it wrong? Okay, let's go on to the next one. Number 2, Serafina put a total of 42 cupcakes into packages. Okay, so right there it says Serafina put a total of 42 into packages. Do we know the total?
Yes.
Yes. So what does that mean if you know the total?
You divide.
Divide. Good. She put 6 cupcakes into each package. What is the total number of packages Serafina used for these packages? So don't get tricked by this down here. It says what is the total number of packages Serafina used for these cupcakes? Well, we're not finding the total in all because we already know how many cupcakes in all. We're splitting those up into groups, right? 42 divided by what? 6. Good. So what did y'all do to solve this? If I don't know my facts, what could I do? Allie?
Do the circle.
I could do circles.
You can do an array.
You could do an array. So here are my packages. You could do boxes, circles. So here's 1, 2, 3, 4, 5, 6. I could do it like that and go ahead and do what it's saying. She put 6 cupcakes into each package, so I could count groups of 6. So that's 12, 13, 14, 15, 16, 17, 18. I still need to keep going all the way until what?
42.
42. So that's 19, 20, 21, 22, 23, 24. 25, 26, 27, 28, 29, 30. 31, 32, 33, 34, 35, 36. 37, 38, 39, 40, 41, 42. And then how many packages did I make?
7.
I made 7. 1, 2, 3, 4, 5, 6, 7. So 7 is your answer. 7 packages. And if you don't have enough room on these warm-up pages, use that scratch sheet of paper. Okay? All right, number 3. A group of 27 students played a game with the hoops shown. An equal number of the students shared each hoop. When it talks about sharing, that should give you a clue that you might be doing what? Bryson? Dividing. Good. So I want you to circle that word shared. Shared. It's in there twice. Okay, and I have 27 students that are sharing the hula hoops. How many students shared each hoop? Okay, so what would I do? Kelsey?
You would like draw dots or lines in the bubbles and stop at 27.
Very good. So these are representing my hula hoops. So I'm going to go ahead and count to 27, putting a dot inside each one until I run out. So that's 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. I can stop. How many are in each group? 3. So 3 students shared each hula hoop. If I had to write an equation for what we just did, what would it be? Does anybody know? Kelsey?
So there was 3 in each bubble because you had stopped at 27.
Yes, but what would the equation be? We divided, right?
Yes. So
Okay.
27 divided by 3.
There you go.
equals- Wait.
We divided it by 4, 5, 6, 7, 8, 9.
9.
And got 3. Okay. Number 4. Point P on the number line represents 2 equivalent fractions. Which 2 equivalent fractions can point P represent? Okay. First let's label our number line. Did y'all do that first?
Yes.
Okay. How do I label a number line? Kaylee, do you remember? Count the spaces. Good. So there's 1, 2, 3, 4 spaces. So that's my denominator. Okay, what next? And then just skip 1. So now my numerator is 1. Okay? So point P is at 1/4. So if I look at my answer choices, are there any I can go ahead and eliminate?
Yes. B.
B, because it doesn't even have 1/4. Okay? So now I need to figure out if 1/4 is equivalent to 1/8, 2/8, or 3/4. Okay? Well, 3/4 would be down here, right?
Yes.
So can those two be equivalent?
No.
No. So now I have 1/8 and 2/8. So let's write it out over here. And what could I do now to see if these are equivalent? Who remembers? Cross multiply. Bryson, were you going to say something else?
Since the numbers on top are the same, you look at the bottom numbers and you would use the 4 because the more you chop it up, the smaller it gets.
Oh, good. So 8 would actually mean it was smaller because the more pieces we chop it up into, the smaller it would be. So even though the numerators are the same, that doesn't mean they're equal because these pieces will be smaller. Very good, Bryson. So you could have looked at it that way. Or if you cross multiplied, you would have said 4 times 1 is 4. 8 times 1 is 8. Are those equivalent?
No.
No. So that only leaves C, and there's two ways you could have checked. 1/4 and 2/8. You could cross multiply again, or I can look at it going across. 4 times what gives you 8?
4 times 2.
2. Okay, so then I do the top times 2. 1 times 2 equal 2?
No.
Yes. So they are equivalent. Anytime you want to get an equivalent fraction, you can multiply them by the same numbers, top and bottom. Okay, so C was correct. Everybody get that one right?
Yes.
Okay, good. Okay, now table. There are 8 oranges in each bag for sale at a store. Which table shows the relationship between the number of bags and the number of oranges in the bags? Okay? Well, let's go back and find our important information. What is important? Allie?
That the 8 has to be first.
The 8 has to be first because it's how many, what, you mean first over here in the chart?
You can take away.
Well, does the 8 represent oranges in each bag or the number of bags?
Number of bags.
No. 8 oranges in each bag. Okay? So that tells me for the number of bags, if I have one bag, how many oranges are in it?
If you have one.
If I just have one bag, how many oranges are in there? 8. Okay, so this side is the number of bags, and this is the number of oranges. Okay, one bag has 8 oranges. I don't see anywhere over here that starts with a 1. Okay, so let's go to 2. If I have 2 bags, how many oranges would that be? 16. And you knew that because what did you do in your head?
You counted.
Just counted 8 more, right? So that would be 16. So there should be 2 and 16. Can I eliminate any answer choices already?
Yes.
Which ones?
H and F.
H and F. Good, because this has 2 bags, has 8 oranges. That's not right. 2 bags has 10 oranges. That's not right. Okay, so these 2 look good so far. So if I keep going, I notice this one has 24 and this one has 32. So we need to figure out which one's right. So if I add another 8, because that's what we're doing, adding 8 each time, what would it equal? 24. Okay, you also can multiply by 8. 1 times 8 is 8. 2 times 8 is 16. 3 times 8 is 24. So our answer on that one should have been G. Okay, any questions on that one?
No.
Okay, put that in your work in progress.